I am Tamil Selvi, Department of Civil Engineering, Rohini College of Engineering Technology, Professor. GPS surveying techniques. The GPS surveying techniques is the position of stationary or moving object can be determined through GPS. When the position of stationary or moving object is determined with respect to a well-defined coordinate XYZ by using single GPS receiver and by making observations for 4 or more satellites, it is called point positioning or absolute positioning. However, if the coordinates of unknown point are determined with respect to a known point is called relative positioning. In other words, relative positioning aims to determination of vector between the 2 points by observation of 4 or more satellites by 2 receivers spaced at the 2 points simultaneously. The GPS surveys may be classified static surveys, the traditional static surveying, dynamic surveys, the rapid static surveying, pseudo-static surveying, and kinematic surveying. This is the point positioning, relative positioning of the satellite. S is a satellite, R is receiver. Here S satellite, R is receiver, and P is pseudo range. So relative positioning and point positioning. Used and application of GPS. GPS is a complex system that can be used in many ways. For basic point positioning using geodetic receivers with a computer and post processing software, accuracy at the centimeter level is achievable. Although the accuracy is important, some surveyors feel that the main advantages of GPS is that it can be used in any weather conditions, day or night. The enables GPS surveying to be carried out over extended periods at any time of the year without restriction, such as rain, fog, and poor visibility. Another advantage when surveying with GPS is that intervisibility between stations or points surveyed is not necessary. This allows control stations to be placed conveniently. Further, with differential GPS accuracy of 100 meters for navigation purposes, 1 meter for mapping and a few millimeters for geodetic positioning is possible. However, the high cost of GPS surveying has restricted the realization of the full potential of GPS till date. So added, there are difficulties in defining heights above the datum such as mean sea level and the real-time data processing and control. Then is the GPS accuracy. Accuracy achievable with GPS depends on several conditions. For example, single or multi-receiver operation, single or dual frequency data, receiver noise level, selective availability on or off, P code available or not, static or kinematic positioning, real-time or post-processed result, extent on data modeling, accuracy of orbits, and fiducial points, previously well-determined coordinates. The ultimate accuracy of GPS is determined by the sum of several sources of error already described in the previous section. The continuous of each source may vary depending on atmospheric and equipment conditions. In addition, the accuracy of GPS purposefully be degraded by selective availability. This is the accuracy. Here, pound positioning, relative positioning, use and application of GPS accuracy.